Have you ever wondered what is happening between you writing your SQL command, executing it, and getting results on your monitor? Is there some sort of a magical being that knows that you want to take your records from the product table and actually do something with them, show them, query them, analyze them, whatsoever? Not really. There are certain elements that are coming to play that we are going to explain and check in details today. But before we will get into that, let's start with a more simpler question. What is a database? And how does it relate to database management system? Is it the same or is it something different? These things we are going to tackle in today's video. So hello friends, welcome back, and let's get into the architecture of database management systems and the elements that are being behind the scenes. Before we will jump into the nitty-gritty details and practical section, let's start with a bit of theory. A bit, but still useful and needed. So, database versus database management system. What exactly is a database? So basically a database can be anything that resembles in any sort of way a collection of organized elements. It can be your daily notes inside of your notebook. It can be your shopping list with the list of elements and items that you want to buy. It can be a list of books inside of a CSV format, right? With all of the details like the author, the title, the number, ISBN. So this is basically a database. So what is a database management system? Database management system is basically a software system that is being used by us as the users of that systems or our services and applications that allows us to read, store, and analyze data in a form of a database, right? So we often say that in our database we have products tables, sales tables, or whatever, like we are doing some sort of analytics, we are querying the database, right? So it's worth remembering that we are not actually querying the database, we are actually querying our database management systems. And the database management systems can be, for instance, Oracle, PostgreSQL, Microsoft SQL Server, MySQL, SQLite, whatsoever, right? So these are the database management systems. But to not overcomplicate, we are saying that we are querying the database. But it's important to at least understand the conceptual difference because our world is built on the databases, many sorts of the databases. But what our software and applications are actually using behind the scenes are mostly database management systems. So having that cleared, let's go into the what is actually a data model. So we often refer to a data model as basically list of elements that are joined in a certain way. So for instance, we have a data model that represents our company, like in ERP systems, right? So we have the, for instance, sales table, we have the warehouse table, we have products table, clients table, and we are saying that they are related between one another. So the sales can be related to products, etc. And this is our data model. But this is more of a specific case of a data model. In a more general terms, a data model is actually a collection of concepts that are basically used for describing the data in a database, right? And I've divided these data models into three different groups. First one is common data models that basically each and every single one of us will face on our daily lives, daily work, etc. And under these common ones, we have relational data models, like general purpose databases with tables and foreign keys, primary keys, indexes, etc. Document databases, where our data is stored in a format of a document. Key value databases, useful for instance for caching. Graph databases, and this is basically the common group. Then we have, I've divided it into specialized set of basically data models. Really popular right now in terms of AI and LLMs, vector databases, then white columns. And the last part, most likely you might not be familiar with that one and may not even came across of those, legacy data models, which are basically hierarchical data models or network data models. In this video, we are going to focus basically on the common ones to understand how the common data model, especially relational data model, and what are the elements behind the scenes of the data model. But before we will jump into that specific section, let me actually try to show you the differences between the relational, document, and vector data models, all based on the PostgreSQL database, where we actually can, not saying should, but can show the examples of the differences between the three of them. So let's switch to the database right now. So a relational data model, right? So relational data model has basically tables and relations between the tables. So when we want to, for instance, save information about the books inside of the table, we are going to create a table named books_r. This table has a name, an author, and a ISBN, right? So the table has columns, attributes of basically an object. And when we are going to create this one and insert some data there and select the data out of it, we see that there are actually 4 records because I've added 2 before we start the video. So the table has actually right now 4 records with the name of the books, Lord of the Rings, Hobbit, and the author of the books, plus the ISBN. There are no enforcements in terms of primary keys, foreign keys. That's why, for instance, we have duplicates in case of the records here, but this doesn't really matter. This is the example of relational data model. Now, when it comes to the document data model, so the concept is similar, right? But instead of splitting the columns into separate elements like name, author, ISBN, we are keeping all of the informations as a single, for instance, JSON schema. It can be JSON, it can be XML, and this is being stored in a single record. So when we are creating such table, we have just identifier and a document in a JSON format. And then when we are going to query this one, we actually see, let me make it a bit bigger here, we actually see that our Lord of the Rings or Hobbit is in a state of a document with exactly the same elements as our relational table, name, author, and ISBN, but in a JSON document format. Obviously, how we are going to query this one and how we are going to use this data in our next, let's say, layers, like the backend layer, front-end layer, it will obviously differ, right? Because the SQL behind the scenes or the way that we are actually querying the data would be different. But here we need to understand the concepts behind the scenes. So the data model, the difference in the data model. So this is the example of the document data model. And the last one, the specialized data model, which is basically a vector data model heavily used by our AI tools right now, LLMs, where we are actually generating a list of embeddings for our data. And these embeddings are then used for basically querying using LLM and our AI models. An example of this one in Postgres, we would need to add a pgvector extension to have the embeddings in a PostgreSQL database. But then we are building a standard table ID, title, and the embedding, which is basically an array, vector array. And then we are adding this information. So Lord of the Rings might have embeddings like this, like array of the numbers that represents this particular information. Hobbit has this particular array. And inside of the database, it is structured like this. So the embeddings are basically an array of numbers that are then used for AI and LLM logic. So this is actually the example of the 3 different data models, all based on the PostgreSQL database where we can actually do it. But in general, you need to keep in mind that those data models, let me get back to actually my presentation again. So when it comes to the data models, we often have specific providers of the database management systems that support exactly this particular data model. So for instance, in case of general purpose databases like PostgreSQL, Oracle, MySQL, whatsoever, you can, as I showed you, keep your data models in different data models, basically in those, like relational data model, document, vector, etc., right? But in case of other systems, like for instance, MongoDB or, I don't know, RocksDB, you will have them as a specific softwares to keep a specific data model inside. So they will not really be useful, not intended to keep the relational data model there, right? Because they were built, for instance, with the document data model in mind. So that's important to understand. Now, moving forward, I started this video with explaining that actually there is no magic box behind the scenes when we are actually writing the SQL and executing it, right? There are a list of elements that our database management system have and that are taking part in executing the query. Now, disclaimer, this particular diagram that you see here on the slide, it will be extremely useful in terms of general purpose databases like relational databases, specifically like Postgres, Oracle, etc. It might not be fully useful in terms of other systems like in-memory databases, LSM-based databases, or different types of databases that are not really the same structure, architectural concepts as the general purpose databases. And the base of this diagram is from the book Database Systems, the Complete Guide. I've provided you the name at the bottom of the diagram, okay? So keeping that in mind, when you are especially working with, I don't know, Oracle, MySQL, SQL Server, SQLite, these elements may be named differently with a slightly different purpose and the context will be present there, while when you are working with a different architecture of the systems, it might not be there. So please check the documentation of your systems. For general purpose databases, this is basically how this will go. And let's get into the details of this one. So let's start with the, let's say, first layer that I've divided, interface and high-level management. So the diagram from the book is pretty old, so there were added some concepts like, for instance, connection pooling that are not in this diagram, but let's not focus on this one right now. Let's just focus on the diagram itself. So the interface and high-level management starts with either a user like myself querying the database, or some sort of a service or an application, or currently popular MCP services that are basically a communication between different LLMs. And this might be one input layer, and the second one, which is slightly right now less, let's say, common, which is a DBA, because currently most of the users might be DBAs of the systems, or the developers might be DBAs of the systems. Also the service application MCP, but you can see that there is a distinction, right? So the first part is actually doing queries and updates, while the second part is doing DDL commands. And there is a difference in these two, right? Because when you are actually using just the standard SQL like the select or update, you are doing slightly different operation than DDL, where you're actually modifying the data model behind the scenes, like adding the table, truncating the table, adding the indexes, etc., right? And depending on actually what you are actually doing, you might have slightly different elements involved. So for instance, when you are doing create table, you will invoke the DDL compiler. So the DDL compiler will check if you are even eligible to do this actual command, if the object that you want to create is inside of the database already or not, so that you can create actually this object, right? Another thing is query compiler. So when we are writing the SQL, let's say select star from and some name of some column, right? So the query compiler is responsible for checking whether the syntax of the query is actually correct and whether the objects actually exist. And the last one, the transaction manager, is responsible for keeping your transaction in check. So begin, end, commits, rollbacks, etc. So this is here represented as the transaction manager. Next, I've divided it into query processing layer, which basically contains two elements, query compiler and execution engine, right? So when we wrote the SQL, like with some joins to the tables, etc., right? And the query compiler says that, okay, this is valid SQL, let's move forward. The execution engine, right, wants to execute it, but execution engine does not really work on select star from products. The execution engine works on an execution plan, which is sort of a different being than our standard SQL, and I will show this to you in a second. So the output of the query compiler is actually the query plan. And this query plan also has additional informations like, for instance, statistics of the table. So how many records are there in the data in this particular table, whether we can leverage an index, whether we should leverage an index, etc., right? So these two elements are basically taking part in getting from the point where you wrote the query and actually executing it, but not touching the data yet from the disk, right? So they are actually preparing the database management systems to give you back the data. Now, transaction and safety layer. 3 elements here: locking table, concurrency control, and logging and recovery. So locking table is extremely important, especially for when you are doing some sort of insert delete operations and other user, other client is doing select, right? Or another insert update. So basically this in-memory element is basically keeping an information whether some elements should be locked and by what process this is locked. Concurrency control, when we are talking about ACID in one of the previous videos, probably I will link it in the top. This is actually important from the perspective of who is querying what, to not basically get into the state where one user is locked and the second user is locked because of the operations that are being done there, right? So this is this thing. And last but not least, logging and recovery. It's basically like a safety net, safety protocol for us when we are actually doing the queries and when we are saving stuff into the database. There, in terms of PostgreSQL, comes into play write ahead lock. So when we are adding the data, updating data, deleting data, it's being saved there as well. Next, data access and storage layer. So here, this is combined into the multiple elements. So let's start with the buffers and buffer manager. So buffer manager is basically a place responsible for checking if the thing that you are requesting can be actually taken from much faster in memory cache. So for instance, you want to query, I don't know, a certain product from a product table, and this exact query was executed like just right before yours. So there is a high probability chance that this exact information is already inside of the cache in memory, and there is no need to get it again from the storage, looking through certain pages from your storage system and get it from there. Rather, it would be taken from the memory of the database. So the buffer manager is basically coordinating this information. Buffers in general, these are in-memory data structures like for caching, etc. So this is basically a communication between buffer manager and the buffers. So there can be information about the metadata, indexes, informations, log pages, etc., etc. Index file and record manager is basically the sort of organizer. It basically maps your data requests into logical structures. So from select star from products, it maps to a specific pages on your storage system and checking whether the specific index is actually useful in terms of using it there. Disk space manager is responsible, as the name suggests, for managing the storage. So there is basically a communication between your file system, operating system, and the actual storage layer where the files for the pages are being stored. And the storage itself is your operating system storage or your storage in some sort of a cloud where actually your data pages from the database are being saved. So this is the 4 typical layers of the elements inside of the database. But what is just to emphasize again, what is the typical flow? So the typical flow is that we have the connection, something that was missing on this diagram, which is basically a connection pooler in majority of modern systems. Connection pooler is responsible for keeping the connections alive, especially when multiple services, multiple applications are calling your database management systems. There might be connections that are currently active, and the connections can be reused by other services in order to not basically create each and every single time new connection to the database, exhausting in that way the resources of the database management system. So the connection is the first one. Then is the input, so your queries or your schema changes. So this is either the DML or the DDL of your either service or you as a client of the database management system. Okay. Third one is the compilation. Query compiler basically checks your queries, your DDL, your general SQL, and gathers also the statistics to create a query plan. And this query plan is then sent for the execution by execution engine. So the execution engine processes the plan, taking under consideration all of the things mentioned in the plan. So for instance, use index or use parallel workers or whatever else, right? So 4-step execution. Then we have this safety net where before the data, for instance, actually changed, before doing, for instance, update, insert, delete operations, then we are saving this information to logging and recovery. We are adding this information to the wall and to the disk, right, to keep them as a durable information. And the last but not least, point number 6, data access. The buffer managers checks, for instance, if the data is in RAM right now, so if it was queried right before and can be reused. If it's not there, then it basically communicates with the disk space managers to get the data from physical pages from the storage back to the originator, back to your client service or the application. So this is the general flow. Now let's get back into the database, and let's basically try to mimic what is happening in this particular flow. So I have this products table that I'm reusing across my videos. So it's basically an information about the products. It has a product name, product code, quantity, nothing special there, okay? What is important is that this product has a certain statistics, okay? And it was last analyzed 12th of December. Now, when we are going to write a query like this one, select star from products, okay? What is happening is that, first of all, query compiler needs to work, execution engine needs to work, and obviously there will be some sort of plan that will be basically a resolution of this information. So when we are going to do the explain select star from DC products, we will actually check what was there, what will be the execution plan. So what actually the execution engine will execute for us. And this is actually the sequence scan on the products. And this is number of records, this is the cost, okay? When we are going to add here like analyze, we are going to get even more information, that the planning time took this amount of milliseconds, the execution time took this amount of milliseconds, how many buffers were hits, and again, what was the command for the execution engine, so the sequence scan. But right now, let's check if it will be the same for a particular element. So we want to get like particular ID from the products table. And again, explain analyze, we will see that in this particular case, the database management system would call 2 workers in order to get a single record from the table. These records, these workers will be executed in parallel. So you will see the parallel sequence scan, you will see the information that the buffers, what buffers were hits, how many rows were removed by the filters, again, planning and execution time. Let's see if we can do something to improve this one, because the products table is a really simple table without even any indexes. So let's check if we first have the index there. Let's create the index, and then let's do exactly the same query right now. And please see how exactly the query execution plan has changed. So how different the execution engine will execute the operation. So right now there is just one single executor, one single worker. The index is being used, index scan here on the PK products index, right? There is an index condition, so ID equals 20,425. One index search, shared hit, one read, and then we have planning time and execution time in milliseconds. So this is basically the flow that is being done behind the scenes. I haven't shown the actually taking it from the particular page. You can check it in my previous video about the page layout, where I'm actually showing exactly how the data are being taken from a particular page based on the PostgreSQL database. Keeping that in mind, I hope that right now you have far more clarity. What is the database? What is the database management systems? What's the difference? and what is actually happening behind the scenes when you are querying your database. You as a client or your service or your application, what elements are being touched? So the query compiler, execution engine, buffers, buffer manager, etc., right? That it's not really like a simple one element structure with some magical being inside that is taking you the data out and giving you it back. It's actually quite complex machine with each element responsible for its own thing. It's worth keeping that in mind. If you want to get into even more details about each and every single element, and especially if you are using different database management systems than more general purpose ones, like I said, Oracle, Postgres, SQL Server. If you are using RocksDBs, for instance, etc., this will be a bit different, or Redis, for instance. So this will be a bit different compared to what I've described right now. Please check the documentation of those database of your selection to have even more clarity of what actually is being executed there. If you have any questions, I'm happy to try to answer them. Not sure if I will have all of the information, but I will try to do my best. Thank you for today. See you next time. Bye bye.